So, in the past 5 years, since when I joined AWS, I had like roughly 100 of teams that I helped overall, trying to migrate to micro-frontends after 5 years on designing, thinking, talking with several companies about micro-frontends. And there are recurring challenges that I have seen over and over again. So during my talks, I try to gather all together and trying to provide, let's say, a honest view on the trade-offs that you are seeing with micro-frontend. So today we're going to talk about a topic that so far I would say wasn't, let's say, streamlined that much with micro-frontends. I think now we are getting in a better position. Okay, so let me see if I can change the slides. Perfect. So majority of the time, let's start with the main problem. When you start with micro-frontends, I usually go in a room or a virtual room with some engineers, and they tell me, "Oh, so Luca, this is our homepage for our e-commerce, and as you can see, we have different components. So what we're going to do, we're just taking that, load remotely, and boom, you have micro-frontends." Yeah, usually it's not quite though, because yeah, micro-contents are different from components, and we're going to talk about that in a second. Who am I? I'm Luca. I'm a serverless specialist in AWS, international speaker, and published author. So that's me in a nutshell. But let's go back to what micro-contents are. So picture 10 years ago when I was an architect in a company called The Zone, and I had to explain to, let's say, quite a few engineers about this idea that I have on taking the principal microservices and moving to micro-frontends. So in order to facilitate the idea 10 years ago, I created this and coined this, let's say, definition of micro-frontends that is still extremely valid. So micro-frontends are technical representation of business subdomain. They allow independent implementation with same different technology. They minimize the code share and owned by a single team. So there are quite a few things to unpack here. I won't go through all the things, but in order to really understand what the micro-frontends is compared to a component, we need to spend a bit of time around these two principles or two characteristics. So first of all, we have a different view of micro-contents. With components, we want to, let's say, have something that is highly reusable. With the micro-contents, we are talking about technical representation of business subdomain. To a certain extent, if you're familiar with domain-driven design, we are leveraging that wave. More simplistic, you need to take a chunk of your logical system and apply into solid boundaries. The other key things is independent implementation. Very often I have seen firsthand micro-contents that are deployed alongside others because otherwise they're not going to work. But that's a problem in distributed system, not only for front end, but also on the back end, trust me. So let's talk about components. Let's take the most simple components that you can find in the world, a button. And the button usually exposes a property, the label. And then imagine that your button starts to get a bit of traction inside your company, and now it's using another portal. And finally, you have also the icon that you can set. Great. Then you start to have new requests like change the border color, different rollover animation, auto size dimension, and disable by default because you're going to use in an amazing form. So as you can see here, the button has a lot of capabilities. And as I said before, what we are trying to do is reusability. We don't want to have different teams that are building exactly the same code, reinventing the wheel, and all the nice principles that we have learned in the past. But the problem is that in distributed system, reusability, to a certain extent, is a form of coupling. Don't take my word for that. There are smarter people than me that talk about architecture. For instance, Neil Ford, this director of architecture at ThoughtWorks, probably one of the most visible architects that you can find over there. And the reality is that when you think about components, you want to reuse, you want to abstract certain capabilities, so you don't want to duplicate certain code, and you want to spread that in across your code. And when you change once, you have everywhere. Now, with micro-frontends, we do something different here. We're not optimizing for high reusability. We want, first of all, to encapsulate the state. This is one of the few anti-patterns I've seen. People that are trying to get the UI decoupled from the state, but the reality is the UI without the state, what it is. So you want to have a state that is encapsulated that will enable you automatically to be context aware. So the micro-frontend knows what is trying to render. And if we think about before in the definition, we are talking about a subdomain, so a chunk of logical system that is living independently. In order to be independent, it has to define clear input and output, usually through events. It can be custom event, it could be an event emitter that you want to use. It can be in a reactive fashion, if you prefer. And finally, are less extensible. I'm not saying are not extensible, are less extensible. You need to be a bit more, spend a bit of more time thinking about how the relation inside micro-frontends and different containers of micro-frontends are working in order to start to extend, reuse, etc. It's totally doable, but few heuristics that I coined in the last few years in order to think if you are designing properly your micro-frontends. But first of all, usually micro-frontends, as we discussed before, encapsulate the state, define clear input and output through events. Therefore, they don't need to expose a lot of APIs. If you find yourself that you have a micro-frontend where you inject 20 properties and functions and wherever, that's probably not a micro-frontend. You are leaking the domain outside the container. But the whole point is that in order to making independent, is that that micro-frontend should know how to behave. And therefore, usually you have maybe an ID that you want to share through a product ID, if you think about the catalog. And maybe if you are in an authenticated area, you know, or you instruct by convention where to find the session token for the micro-frontend. But that's pretty much it. You don't need too much stuff. The other thing is micro-frontends are context aware, so the encapsulation of the state makes that very crystalline clear. Don't optimize for usability at all costs. As I said before, you can, but that's not what you're optimizing for. With micro-frontends, we want to reduce the external dependency from a team. And therefore, if you start to have a lot of things shared and only a single team maybe can change one thing, you are going to create coupling and that is a problem because you are going to invalidate the idea of distributed system where every team try to work independently and at its own pace. And last but not least, micro-frontends are not as fine-grained as components. Usually, if you think about the UI, you might have, I don't know, 50, 70, hundreds of components. When you have like less than 10 micro-frontends, roughly, in the same view, because are built by different teams, trust me, is already a lot. A good average, if you decide to go in that way to split micro-frontends, can be 4 or 6. Again, you have to think that are more coarse grain. Splitting up a coarse grain micro-frontend is easy. The other way around is way more difficult. So at that stage, when we started to discuss about micro-frontends, I have also to think about one of the different problems that you find in an architecture. Usually you identify what are your micro-frontends, so you identify the boundaries, but then you need to compose these micro-frontends, how you can at runtime load these micro-frontends, where they live, how you can reach the endpoints. So I created in 2019 this idea of decision framework. And it's basically 4 decisions that you need to make in every architecture. I tested out on client-side rendering, edge-side rendering, on server-side rendering, and any other flavor that you can think. And it turns out that is always the 4 decisions that when you have that clear, you will be able to design proper solution. So you need to identify micro-frontends. So if you want to have one micro-frontend per view, multiple micro-frontends per view, you need to compose them. So how you're going to have something that is remotely living somewhere in the web inside your application. You need to decide how to route. And obviously, there are different ways if you are doing client-side rendering or if you do server-side rendering. And finally, how you want to communicate. So how micro-frontends are communicating together. And those usually are the 4 decisions that you need to spend a bit of time at the beginning in order to nail it, and then use them as a North Star for following with the rest of the system. Now, I want to spend a bit of time on the composition because server-side rendering, I think we struggle a lot in the past for having an easy way to build these things. Majority of the time, what we were doing, especially at the beginning of the micro-frontends journey, it was called transclusion. So you have a placeholder where you replace with HTML fragments. That is a technique that is still in use, especially for not JavaScript land implementation. Like if you're thinking about Java or .NET, whatever, there's still a sizable amount of company using them, and therefore they're using that way. But the composition is basically the idea of how I can load this stuff. inside the client or the server. In the case of the client, usually you have an application shell that is the dotted line you see on the left of this slide, where has the knowledge on where to find and fetch this micro-frontend. On the server side is what I call usually a UI composer, because in reality is slightly different from an application shell. Is usually let's say a bit of JavaScript that has maybe the header, the footer majority of the time, and then you pump data, or better, JavaScript chunks that will know where to fetch the data, or HTML fragments. We will see more in a second. But the idea is that everything is happening on the server, and we need to understand how we can implement these things in a modern framework, the most used one, I would say. So what is the main challenge on server-side rendering micro-frontends? The composition. Why that? Because there are so many ways and variables that you need to take into account that is not only related to code, but also to the infrastructure that you're running. And if you are working on cloud providers, you need to understand the different options that you have. Now, if you think about Next.js, that probably is one of the most used framework that I've seen with AWS customers, you have this idea of multi-zone. And multi-zone is the possibility to take a complex application that is, let's say, a monolith, and then split it up in different zones that are smaller application. You have hard and soft navigation, depends of if you are switching between zone, or if you remain inside the same zone, you change the view. But the beauty of this approach is that in this case, in this example, if I have an home page that for any given reason is failing, the rest of the application will still work. So the idea of using micro-frontends, especially for mid-sized, large organization, is mainly for resilience, is for enabling multiple teams to work together. And this has to be expressed also in your architecture as well infrastructure. So in this case, for instance, you have like a very vertical approach. Then obviously this is a diagram is difficult that you have like a perfect definition of the API that will be sliced perfectly with your front end. There will be some overlap in certain domains, but overall, the idea is this one. And the beauty of this is that if you have a CDN in front of that, and then you want to operationalize your micro-frontend either in a container or in a Lambda function, if you are in AWS, you can do that very easily without too many troubles. Again, in this case, if I'm responsible for the checkout, I can work on the checkout, iterate on the checkout, deploy my changes without coordinating with all the rest, API and front end, without any problem. That's the dream come true. Because the reality is, if you slice properly your micro-frontend and you don't go too granular as we expressed before, you avoid and reduce the external dependency, you can really have an end here. I've seen firsthand teams that were moving from monolith to micro-frontends, moving to two free deployments per month to 25 per team per day. So this is doable as long we, let's say, have the right mindset. We create the safe net for developers. Now, a classic example here, for instance, is Formula One. So if you go right now to f1.com, you will see that basically they completely changed the way how it's built. At the beginning, it was a monolith. It was fetching data real time from a headless CMS, and it was painful. So we started to redesign this thing, and I don't want to spend too much time into the icons that you can see here, but I wanted to provide the concept. So usually in a server-side rendering with micro-frontends, what you have is a CDN. In our case, is this CloudFront thing that you can find there with some static files that are hosted in Amazon S3. And then that is the entry point. That is also responsible to set up the different origin. And origin in this case is as simple as, okay, so the checkout or the news or the F1, I don't know, a video will go in that specific path, and you route through that. But there's infrastructure that takes care about this. So what you are really working on at the end of the day is this part here. You're going to have an application load balancer and that is operationalizing your cluster, so you are capable to, let's say, redirect traffic towards a different part of your configuration of your cluster. It can be a container again or something else. But the beauty of this is that those are completely independent. One of the beauty and interesting thing that Formula One have done is that then they started to apply different TTL in the CDN, time to live, for different content. So if, for instance, if you are in the news page, obviously you need to be super snappy. You cannot cache for long. But if you are, for instance, in the video page and you are uploading the video only after a Grand Prix, that probably you can cache that part. What does it mean? That now not the entire application needs to address the millions of fans of Formula One, but just the video part needs to have volumetric around that and just have enough capacity for handling the traffic that they have. The CDN will take the heat the majority of the time. And that is, in my opinion, a beautiful approach. Another approach is using module federation that probably you have heard about it by now, is a fantastic library, in my opinion, that enables you to dynamically run code from another bundle. And that works on client and server side. So if you want a very simple representation of this, imagine that you have on the left multiple micro-frontends, and you use Webpack in this case with module federation, but the new version can work also with Vite, RSPack, and many others. And you see that it's basically what it does. You write your micro-frontend, Webpack is generating some JavaScript chunks, and then suddenly you're loading React or Solid.js or Angular, whatever it is, and you see that the catalog and my account are using exactly the same chunks. So module federation will take care, if instructed correctly, to load just once. So you don't have to deal with dependency management, and you can also have multiple versions of the same framework or multiple frameworks together. Now, it's not something that I recommend, but sometimes it's necessary. So because of that, with Next.js, I've seen quite a lot of customers that are splitting their micro-frontend at the page level. So imagine that you have the catalog page, and you have the catalog with all the different session and the details. So you can split them up at the page level, and you can lazy load this page based on the request that is coming. Maybe you have a part of the website that is not hit very hard, and other parts that are always hit. So therefore, you can even lazy load a specific part on the fly, and that simplify everything from deployment to many other things, because you are sure that the only thing that you are changing is the one that will be deployed, and the rest will work as it was before. Similarly, on module federation, another approach that I've seen with Next.js is having arbitrary code that is coming from different sources, like, for instance, advertising server that has to be injected inside Next.js. And in this case, one of the main suggestions I have is sanitizing the information that are coming. But basically, you call the server, you take the HTML fragments, you squeeze inside your React components, and then suddenly you have your micro-frontend that is server-side render and send through there. All of them are happening at runtime. All of them are designed in order to have like strong boundaries, and you can play with all the rest. I think it's a very neat approach. Now, let's see another framework. Obviously, we were talking before, and I heard we were talking about a server island that is one flavor of micro-frontends. And I think this one is an interesting one, and it's similar a story with React Server Component. I'm not touching that because currently Vercel is working on providing more capabilities around micro-frontends. I've tested and followed the recent news where you can start to have a lot of goodies around micro-frontends if you're working on Vercel, but that is just the beginning. There is way more that they are working on behind the scene. So for Astro Server Island is this idea that I can render, or better, server-side render a portion of the UI and then atomically update that. So in order to pass this message, I thought, okay, what can I build in order to make very simple? So I created basically this idea of a dashboard, like you have an observability dashboard in any system, right? And this dashboard is completely different. So you can find the code in behind this QR code. Each dashboard has, imagine that is developed in different places, but this dashboard at the beginning has all these different widgets that when you click, enter inside a more complex scenario. So we have system health, API latency, user activity, and so on. Now, the beauty of this approach is that what happens when we are calling the dashboard? Well, perfect. So the user browser sends a request to an application shell that is running on the server that is composed by the header and the footer, the things that we have seen before. And the first thing that does is generating dynamically all the different things that I need based on a discovery service that I created in order to make sure that when I change something on a micro-frontend, I don't have to change the application shell. The application shell should be as stable as possible, completely decoupled from the rest of the system. So at that stage, then the application shell starts to retrieve all the different micro-frontends it needs to fetch. It calls their API. Those are rendering the UI, send their HTML fragments, compose the final, let's say, UI, and then send back to the browser. This is just the first iteration. From that point on, every single part of the application is completely independent in the rendering phase. So that is super cool because that means I can apply different, let's say, refresh rate for different widgets, and that will work out of the box. Now, how have I implemented that? It's very simple. I created this custom component called Remote Island that receive an endpoint because, as I said, I retrieve this endpoint remotely from a JSON that I let's say fetch on the fly. And that means also I can hide and gracefully if someone doesn't work or is not fetchable. I can pass a description and the title for these specific things, but let's zoom in inside the remote island. So remote island is very simple. It doesn't do anything magic. So it's just retrieving the endpoint and let's say passing a specific header that signal to the system that is usually what we are expecting is a text HTML. So at that stage, we are retrieving the HTML fragments that then will be transcoded inside where? Inside this fragment here. So the cool thing is that Astro has this set HTML that enables you to inject some HTML out there. And the HTML is nothing more than, we will see in a second, a bunch of JavaScript and HTML render that we want to do this. So in order to set up the micro-frontend for handling this part, you just need to set, obviously, the output as a server. And in this case, was standalone because I was using, let's say, also a Lambda function for rendering this part. Now, usually when I write the code for a micro-frontend, I always have this idea on developer experience that I need to test end-to-end. I don't have to spin up a bazillion or other things because otherwise it becomes clunky, the developer experience. And I was used when I was creating Monolith to work everything inside a single repository. So usually what I do is creating, let's say, these checks that sees if I'm running standalone or I'm running a production with as a micro-frontend. So in this case, for instance, I'm providing a bit of HTML so I can test it locally and also in isolation if I want. Or if I'm in production, I will have only the API latency. I think this approach is very simple. You will see the code there, but it's nothing magic. But the cool thing is that it has a very nice separation because we have thought thoroughly on how these things will work all together. Now, these are just some of the experience. There is another important thing that I want to highlight when you work with server-side rendering that is will boost the performance of your application, that is caching. Very often people think that, okay, so we have the cache in the browser, we have the cache at the CDN level, but there is also the memory cache that you can apply. There are, let's say, some of the, let's say, big brand that I had the pleasure to work with is, for instance, BBC, that publicly they shared how they have implemented BBC News. And you will see that in their architecture, they have multiple levels of in-memory cache that are applied also for storing chunk of HTML fragments that are then injected into a UI composer for then rendering the different parts. The beauty of this approach is that it's not only that you need to optimize heavily the code that you're writing, but also the infrastructure around that. Because if you know upfront that certain HTML doesn't have to be rendered every time or every request, and you have a high volume of traffic, why not storing certain part that is, let's say, render, and when the cache is evicted, you start to fetch it again. That will simplify drastically the management of your infrastructure as well as reduce the cost. So that is an important aspect. Now, with this talk, obviously I didn't discard all the other things that are important in micro-frontends. Very often you don't hear about these metrics or these mechanisms in many other things, but governance is a key aspect of micro-frontends. How to update, for instance, a specific library that is shared across micro-frontends, or how you can handle, for instance, the budget size for performance, or how you handle events management, or can you structure that in a way that everyone is writing the right things. Security is another important aspect, especially if you're working in specific industry like financial or insurance, just to name a few. The other part that for me is important is observability. Very often, we are looking only on core web vitals, but the problem is what happens if at 4 a.m. In the morning on Saturday night, you are going to be on call and you receive, let's say, a problem inside your system. If you have micro-frontends, you need to identify very quickly who is responsible for. And therefore, observability will help the team that is first layer support to, let's say, identify who is the right team, but more importantly, to provide, let's say, the right, let's say, solution for the problem. Finally, if you want to learn more about Micro-Frontends, I just finalized the second edition of Building Micro-Frontends book. It will be released at the end of November physically, but at early November digitally. So if you want, you can absolutely, let's say, read about that. And secondly, I have like a fortnightly newsletter that I create for a few years about Micro-Frontends. It's completely free. I'm just trying to spread the love about this architecture that I believe I cannot define as a game changer, but it's one of the tools that we were missing in the front-end community, and I had the pleasure to spend a lot of time with this. Next year will be 10 years anniversary for Micro-Frontends, so I would say it's not as new as you can expect, and many customers or many big brands out there are using heavily and extensively Micro-Frontends. That's all I got. Hope that you enjoy. I will take some questions, but if you have more, feel free to reach me out at my email, as you can see there. And I'm always happy to chat with the community and try to share as much as I can with what I do.
Thank you so much. Great talk.
Thanks.
We have a couple questions from the community. So, Paul, will you bring this up? And I now kind of see what you like about your manager position of telling people what to do. That is a really good feeling sometimes.
No, not good. Definitely not good.
Just telling people what to do, not the whole rest that comes with that. You can keep that part.
Sure,
So, first question. In your opinion, what would be the best approach to use micro-frontends built with Vue or React with a template-based frontend like Django or something?
It's a challenge. So it depends from your constraint. The problem of everything, as I was discussing in our podcast, it's not that I can tell you, oh, use this library and it will work out of the box. It really depends what you want to express inside your system. So sometimes you want to, for instance, if in your situation you have these React and Vue components that are not owned, or you cannot have a say on how they are built, and you are responsible for the Django part, and you have third parties that are doing that, they're building the micro-frontends, then probably you need to have strong isolation. So you need to find something like iframes potentially that could work. Now, iframe are terrible for several reasons, but at the same time offer a security that is unfair at the moment. There are some ideas to replace them, but it's been a while that we are talking about Shadow Realm in the TC49. We are not there yet, and last time that I checked, we are still in, I think, second phase of the proposal. That is annoying, but that will help. It's basically an iframe without all the burden of having all the iframe security without the burden of having all the window and the rendering part that is completely useless. But again, it really depends. For me, Mod Federation helps a ton, but it could be that you can even do, it depends if you're running on the server everything, you can even inject server-side, HTML fragments with some JavaScript that is hydrated on the client, and it could be an option. You can wrap inside web components. Recently, Cloudflare release a very interesting project called Web Fragments that is basically defining it like the Docker container for frontend, where you isolate everything and inside your system. They play at the moment with a bit of iframes and other things that are going to evolve because it's very new project that they are starting to use in the Cloudflare migration towards this micro-frontends approach. But again, there are plenty of solutions out there. It's difficult to say this is the right one because I don't believe in, probably because I'm old now, but I don't believe in best practice or in a solution that fits them all, because it doesn't exist in my experience. What I have seen is that you can get similar outcomes with different technologies. You just need to understand what you need to express inside your system.
All right, we'll go on to the next one. But Jan, I hope that Web Fragments makes it in the next dev brew. Just saying.
Yeah, maybe.
If you want a hook, I can do that.
Ooh, I'll get back to that. What is your approach to sharing common dependencies? Runtime dependencies via an import map is horribly inefficient. How do you handle shared dependencies? And I think I know the answer, but I'm still curious.
Okay, so let's start from the basics. Because you're loading everything at runtime, doesn't mean dependencies should be loaded at runtime, first of all. So build time is still valid. There is nothing wrong with that. Now, I can tell you an interesting story. So the problem of shared dependencies is not the technical implementation, it's the long-term maintenance. So the reality is you start with all the good intention of the world, and you will create the best code, super polished. But the thing is, in a year time, I can guarantee you there will be a new developer or someone leaving the team that will screw up big times that part. And it will come at the point where, oh, by the way, we have this deadline. Let's take a shortcut and let's squeeze in inside the shared dependency a specific thing. And I know that we all been there, all of us. I struggle to see someone that didn't. And the reality is you need to create governance around shared dependency. In my opinion, shared dependency should be loaded at build time, not runtime. Mainly because it's easier to catch up an issue instead of blowing up in the face of the user. So we are building code not for the sake of writing code. And I know that is naive now thinking about that, because I was a developer for decades and I love writing code day in, day out. But the reality is there is someone that is paying us to generate value for the users. And therefore, our first responsibility is try to do the best for our users. So if I can, let's say, avoid a potential issue in production, loading at the build time some stuff, why not? There are certain benefits of doing that, because you will have a set of procedure like, I don't know, integration testing, end-to-end testing. Maybe you have manual QA, so you will have also the manual QA doing that test. And also you will pin out your code working with the specific version of that specific dependency. That is beautiful. In the past, 10 years ago, when module federation didn't exist and all the goodies that we talk about nowadays didn't exist. In my company, we created a library that basically we designed in a way that it pinned the major version of a shared library or a shared component. And it was loading at runtime the minor and the bug fixing version. That because if you rely on major version for breaking changes, then you can iterate very fast for all the different teams that are behind this shared library. In our case, was a video player and the payment micro-frontends. They can deploy at the speed that they want, but if there is a breaking change, I force them to get let's say, a bump up in each single micro-frontend using them, because we go through a series of checks, and they can create a governance around that. That could be a request for comment for discussing how the APIs looks like for the breaking change, or how to implement a specific optimization. So these kind of things in distributed system matters, because we are reducing external dependency, but not reducing the communication. Communication has to be high as it was before, even sometimes more than that. But the reality is you will spend more time in your code, taking your own decision, have a skin on the game, and be part of the solution more than just writing code. That I think is the best position for every developer nowadays.
Thank you. I think we're coming up to the last question.
Sure. Here we go.
Our former speaker, Alexander Lichter, has a great question. Why do you think micro-frontends are not more popular in the real world?
It depends what it means popular. For me, are not a solution that are for every single workload. Monoliths are still valid, and that is true for frontend as well as for backend. So yes. Let's start from that. I can tell you currently from the companies that I followed, the largest company in the world, as well as, let's say, mid-sized company or SaaS companies are using micro-frontends because they can innovate faster, and they can have, let's say, a certain level of agility that when designed properly, I highlighted when designed properly, it becomes, let's say, a competitive advantage for many reasons. Now, the challenge we have seen, and it is both opinion probably now, is that designing architecture is not as simple as stitching together libraries. So in the last 15 years, what I have seen as a developer on the front end was, okay, so there is, I don't know, Facebook that came out with Flux and with React, put that together, done. But all the decisions were made by them. You the only thing that your decision was, I picked this library and I picked that. I use my linter in the configuring the way that I want. I use TypeScript over JavaScript or vice versa, and pretty much it. So I think it's important to understand that micro-frontends are not the solution for all the problems, are a solution for a specific problem. Not every company requires them. And still, nowadays, I would say with all the modern frameworks, you have a great developer experience that you can serve millions of customers just with that. So I truly believe that, like for microservices, like for any other type of architecture, you need to really find an environment that needs micro-frontends. You don't need to do like a small, let's say, website for I don't know, an event that will be thrown away in a month, written in micro-frontends. Use whatever tool accelerate your path to generate value for your users. That's the most important thing for me.
That was a great closing statement. There are a couple more questions in the chat, so if you maybe have 10 more minutes to chime in the chat, I'm pretty sure the people that have questions would very much appreciate that. Thank you so much.
Thank you for inviting
Thank
me.
you,
It was
Luca.
an absolute pleasure.